Okay, this is the beginning of chapter 6. In this chapter, I'm going to open with just kind of a preview of what is to come and what we're going to be covering in the entire chapter. So first of all, let's review that we had linear equations in two variables that look like in general form, as your book calls it, ax plus by is equal to c, where a, b, and c are real numbers and x and y are variables, and the only stipulation being that a and b can't be 0 at the same time. So we're going to be solving systems of these, which means that we're going to be solving two linear equations in two variables simultaneously. We've actually already seen this in chapter 4.3, I believe it was, that we did some examples like that. But we're going to revisit them, and we're going to be doing that in three different ways. Number one, graphing. Number two is substitution. And number three with the elimination or addition method. Now what we're going to see is that when we have systems of linear equations, we can come up with three different types of solutions, or three different types of systems. And when we solve them, we'll come up with three different types of looks, and our solutions will also have those three different types of looks. I want you to make sure that you understand the difference between the naming, the type, the way it looks, what it looks like when we solve it, and then actually having a solution. Now your book doesn't have quite the detail on the types of systems. Your book just refers to them as consistent, I think, and inconsistent and independent or dependent, I believe. It's not quite as typical as of a method of naming as I've seen in the past. So my naming conventions are going to be related to two different types of characteristics. One characteristic, consistency, meaning that we have a solution or not, and dependency, whether they're the same equation or their own equations. So the first type of equation that we have is consistent independent solution. The consistent independent solutions, we're going to have two unique equations, the consistency, and independent, meaning that they're going to give us a single solution. This is kind of like when we dealt with one equation, one unknown, where we had a single solution called a conditional equation. And when we solve these, we're going to get x to be equal to a number and y to be equal to a number, and our solution is going to look like an ordered pair, an x comma y. Now the second type is an inconsistent independent system. Inconsistent meaning we're not going to get a solution, and independent meaning we have two separate equations. This is like when we had one equation and one unknown, that we got contradictions. So when we solve these, we're going to end up with a number equals a different number, which is a false statement. There won't be any variables present to get that false statement, mind you. And the solution that we'll get is we'll write no solution, or we'll write a null set. And the last type of equations systems are going to be consistent dependent. Now consistent means we do get a solution, and the dependent part referring to the fact that the equations are exactly the same. This is like one equation, one unknown, where we had an identity. And what we'll get when we solve these is one single number equals another single number, and no variables will be present again. And this is a true statement. And the types of solutions we get here are infinite solutions. Now before we always said all real numbers, but remember we have both x's and y's to be all reals, so this is a much bigger solution set, and therefore we call it infinite. So what I want you to look at here and study a little bit on your own are the pros and cons of each method. So the graphing method that we're going to go through first, this is a great method for visually understanding what it is that we're doing. The problem with it is it's not always exact, and it doesn't always work with every single system. And sometimes just the graphing of these things is such a pain, or the fact that the ordered pair solution we'd have to guess at, and guessing's never okay. Substitution method, that's going to be great because we've already done substitution, but when fractions are involved, this can be quite painful. And finally, the elimination method, fractions easy as can be to deal with. The cons of it, it's entirely new, and it's going to be a little confusing to us at first. So our next video, we'll get into discovering just how to do the first type graphing.